Okay, so when we're factoring, we have x squared minus 2x minus 120. Remember, trinomials, they usually break down into two sets of parentheses. We always have to look for greatest common factor first. Does all three of our terms have something in common? No. No. The last two do. They're both even, so 2 is common in both of those. But we don't have a 2 in the first term. So there's not a GCF for all three terms, so I can just start breaking it down. Now, these are the easiest to break down because we don't have a weird number at the front that's going to cause our calculations to be off. So if the number in front is a 1, like it is here, then we can just think of factors of 120 that add up to a 2. So if you need to list all of your factors, and you might, I mean, you've done these so much that you probably already know what it's going to be, but if you're not sure, you can always go off to the side and list all of your factor pairs. And what we're looking for is things that multiply to get 120 but add to get 2. Let's see here. 5 goes in 24. And 120 has a lot of factor pairs. I'm getting closer though. I think 8 goes in. 15 times?
12 times 10?
Yeah, I think we are ready for the 10. So 10 times 12. And then that's the pair that's a difference of 2. So I know that I'm going to use the 10 and the 12. Now the question is, we need negative 2. So I know that the front of my binomials are both x, because x times x is the only way to get x squared. But in order for these to add together to be a negative 2, one of them has to be negative. Which one?
The 12.
The 12. So I'm going to put minus 12 plus 10. You could put plus 10 minus 12. It doesn't matter. It's still the same answer. And then that's my final factored form. You can always double check by foiling it out and making sure.
Okay.
Uh-huh.
You can put the 10.
Okay, so 35, we have 6z squared minus 5z minus 6. We're still factoring. Is there a GCF? Because you always want to check for that first. No, there's not. Okay. We know that it will break down into two sets of parentheses.
The temptation is to do 3z
Uh-huh.
instead of doing the 6z.
And that's exactly what, if we do guess and check, that's how I would start. I would start off with, because there's different ways to get 6z, because you either have 1 times 6 or 2 times 3 to get 6. And we would have, since the front and the back are both 6, then we know that either 1 times 6 or 2 times 3. If I'm doing guess and check, I tend to start with the ones closest together. That doesn't mean they're going to work, but I would do 2z times 3z. And then if I'm going to stick with the 2 and the 3 on the back end as well, I'd put a 3 and a 2. Now I'm just doing guess and check method. I'm just plugging numbers in that I know that are going to work as far as the multiplication is concerned. Because if I start doing my FOIL, my F of FOIL says first. So 2z times 3z, would we agree that that's 6z squared?
Yes.
Yeah, so that's okay. If we go to the back end, that 6 that's on the back, would you agree that 2 times 3 is 6?
Yes.
Absolutely. The mystery is the middle term.
Right.
The middle term comes from the outers and the inners being multiplied or being combined after you do multiplication. So this is how we know if we guessed the right terms. Is 2z times 2
4z.
is 4z, and 3 times 3z is 9z. Can I get a negative 5 if I have a 9 and a 4?
Yes. If you
Yes. If the 9 is negative and the 4 is positive. So I actually did guess right. I just have to fill in my signs. And that's my answer. 2z minus 3 and 3z plus 2. And that's doing guess and check.
All right, what was the other besides guess and check?
Box method. So that's what I was going to show you next if you didn't remember this. Box method We draw a box with 4 squares. We'd put our first term in the upper left. Oops, I don't know why I put a 6 there. And we'd put our last term in the bottom right. And then we multiply the A and the C, which is the last and the first, which happens to be 36 because they're both 6. 6 times 6 is 6. And then I think of factors of 36, which there's several. I've got 1 times 36. I've got 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And we're looking for factor pairs of 36 that add to be negative 5. It'd be the 4 and 9. So factors of 36 that combine to be negative 5. So since I need a negative 5, I know that it's going to be a negative 9, and I'm just going to put negative 9z here, and I'll put positive 4z here. Then do you remember what we did after this? We find the GCF of each row and each column. The GCF, let's do the rows first, so going across. 6z squared and a minus 9z, they have a 3z in common. And the bottom row, 4z minus 6, that has a 2 in common because they're both even. Now if you look at your columns, 6z squared and 4z, they have a 2 and a z in common. And the negative 9z and the negative 6 have a negative 3. So what I have here in green end up being my answers. 2z minus 3 and 3z plus 2. Matches what I got when I did it the other way.
Now,
So if you want a more systematic way of doing it, box method. If you're okay with guess and check, then that's what I did on the top there. Okay, so on this one, the directions say solve using the principle of zero products. Remember, that means if I have A times B and the answer is 0, what can you tell me about A and B? Either A has to be 0 or B has to be 0 if the answer is 0, right? Okay, so that principle applies to this problem because I have two things being multiplied together. So either x minus 3 equals 0 or x plus 2 equals 0. So when we solve, we have two little baby problems to solve here. So I have to add 3 to both sides on this one, and I'm going to have to subtract 2 from both sides on this one. So I am going to get two answers. I'm going to get x equals 3 or x equals negative 2. So two answers on that one, 3 and negative 2.